The star we call the sun, the perfect fire of the ancients. Today, this perfect fire is under intense scientific study from Earth and by spacecraft. The newest project dedicated to exploring the sun will be the voyage of the spacecraft Ulysses. To the poet, the sun is the god of life and poesy and light. To the meteorologist, the engine that drives the world's weather. To the biologist, the giver of life. And to the physicist, the sun is a marvelous laboratory for the study of stars, for it is the only star that is close enough to study in detail. For centuries, scientists who studied the sun saw an incomplete picture, for the Earth's atmosphere blocks some of the sun's radiation. Then spacecraft reached above that barrier and the picture began to clear. In 1973, Skylab and its array of powerful instruments made it possible at last to see the sun across its full spectrum. Skylab's discoveries fired the imaginations of scientists and triggered today's increased interest in solar research. Their research expanded to include the entire heliosphere, that region of space dominated by the sun and the processes that go on within it. But from the Earth, scientists have been unable to observe a most important region of the sun, its poles. That's because instruments near Earth can't see over the top of that great sphere. Yet scientists believe the sun's polar regions may hold unique clues to the nature of our nearest star. Only by flying above the poles will they be able to measure the processes that go on there. So to extend our research into those regions, NASA and the European Space Agency have created a mission named Ulysses. Ulysses, with its package of 9 scientific instruments, will be launched in May 1986 on NASA's Space Shuttle Challenger and a Centaur rocket. But even those launch vehicles are not powerful enough to lift Ulysses out of the ecliptic plane, the plane in which Earth circles the sun, and send it hurtling directly over the sun's poles. So first we must send Ulysses to Jupiter to steal the extra energy it needs. Jupiter's gravity will act like a huge slingshot as it bends the flight path to lift Ulysses out of the ecliptic plane and whip it back over the sun's poles. Its mission will carry Ulysses over both of the sun's poles to probe the sun's corona, the diaphanous crown that we see only during an eclipse of the sun. The solar wind, a gale of charged particles that stream from the sun, and the sun's tangled magnetic field as it is carried into space by the solar wind. Finally, some of Ulysses' instruments will detect and measure cosmic rays coming from our Milky Way galaxy. Scientists have many reasons for sending a spacecraft over the sun's poles. For example, many clues have convinced scientists that the corona and the solar wind that flows from it are very different at the sun's higher latitudes. With data from Ulysses, theory should become fact.
I was thinking about our being inside the magnetosphere at this point.
Another reason is simplicity itself. Near the poles, where Ulysses is bound, the physics of the sun is expected to be simpler and therefore easier to understand. For the sun is far from being the perfect fire of the ancients. Instead, it is a seething thermonuclear cauldron. Vast quantities of energy burst from the interior to create unimaginable turmoil at the surface. And as the energy pours outward across space, it carries ever-shifting electric and magnetic fields throughout the solar system. What adds to the complication is that the sun rotates, and material at the equator rotates faster than material near the poles. As a result, the sun's electric and magnetic fields near the equator become tangled and complex. And additional complexities originate in the corona. Here, the solar wind springs into being and blows outward in all directions. Skylab made an important discovery about the corona and the solar wind. Huge tears in the corona called coronal holes. These dark patches are regions where vast clouds of solar wind particles have escaped. The particles move at many different speeds, and so the higher energy particles bunch up behind the slower ones. The result is a traffic jam that snarls the magnetic field lines around the sun's equator into a convoluted tangle that constantly twists and knots and becomes ever harder to understand. Ulysses physicists will also study particles that originate during solar flares. Solar flares are the most catastrophic and energetic events on the sun. The particles they yield have extremely high energies. These high-energy particles explode outward, leaping from one magnetic field line to another, and complicate matters around the sun's equator even more. But at the poles, there should be less turmoil and therefore greater simplicity. That simplicity should bring valuable insight into processes in the corona. While Ulysses is near the poles, it will also measure cosmic rays, bits of matter from suns more distant than our own. Cosmic rays were born in cataclysm, and surely bear tidings of those portentous events far away in the galaxy. Events like the deaths of other stars. But some of the messages from those distant stars have been greatly changed by the magnetic field near the sun's equator. So changed that scientists can learn almost nothing about their nature before they entered the solar system. Above the poles, however, incoming cosmic rays should change very little. Ulysses will spend almost 5 years on its great journey of exploration, a small and distant voice millions of miles from Earth. Yet it will return an unprecedented scientific harvest. A harvest to enrich and expand our understanding of this special star, the sun.